to this call. It says here conceptual content, but it's kind of a follow-up also from CMS Kickoff on why you need to know your content better than AI. So over to you, Marc.
Oh, thank you very much, Giannis, and thanks for the invitation today, and great meeting everybody. I've condensed a follow-up, slightly expanded version of what I presented in Florida about a week ago into this presentation. I will move slightly fast because I want to leave enough room for questions at the end, but there is a lot of information I want to cover. So I'm Marc Salvatierra, coming to you from Los Angeles, California. Going to be present today on conceptual content, modeling content semantically. Brief disclaimer, all this information are my own views, doesn't represent the position of any employer. Briefly about me, I've been working in content management now for 25 years, several different industries and organizations. I've spent the bulk of my career now at ICANN, rolled out 30 plus sites. I've had many web and content roles, but all along the way I've modeled content, and it's something that I really love to do. So just a brief sample here on the screen of some of the technologies I've worked with. So CMS, of course, but also DMS. I've managed product for content management systems. And the last few years, I've been really getting more heavily into semantics. So I have one foot in the content management community and one in the semantics and knowledge graph community. To set a vision for what we're going to talk about today, I'm going to credit this to Michael Ian Tosca. It's an area he's worked in a lot. And he said this particular quote here actually just this last Friday, so just a few days ago. And it's on the next generation of CMS platforms. And what he says is the next generation of CMS platforms will be built on RDF graphs, property graphs, or a hybrid of both, but not on relational models. The result will be intelligent graph-native structured content that is continuously refreshable, inherently connected, and ready to be mined by AI systems. I think it's a great quote, it's a great vision, and it feeds into what we're talking about today. Because if I personally believe in that vision, I'm gonna need a content model that works with that kind of system. So the objectives for today's presentation are a temporary thought experiment. So imagine your content model and its content decoupled from the CMS and from channels, and so left only with content meaning. Then refactor the content model semantically using ontology and resource description framework. And finally, connect that conceptual content model with other ecosystem models and with machines. So in this case, AI. So I've rendered what it would look like conceptually to have a conceptual content model. So you see down in the bottom right, the CMS, not totally forgotten, but for the moment, just sort of floating away with its channels. There's an organizational model up in the upper right. And this is as a stand-in for your traditional domain model, your business model, your ecosystem models, your enterprise semantics. Most importantly, on the left is the conceptual content model. So what's different here about the traditional content model is that whereas you might have page content, and so that's represented in the white, and you may even have generative engine optimization going on, what we've done is wrap that content in resource description framework, RDF, and then we've gone beyond that, really, which is the page level, to interconnect these different RDF elements. And so we end up with a self-contained conceptual content model of meaning. And what we can do with that is take elements from the model and connect them to the org model, or take the entire model itself and connect it to the org model for really a unified experience. And I'll demonstrate here in a moment an example of that. Some quick semantic web history. The original web was envisioned by Tim Berners-Lee as a web of linked documents. And you may know that by the late 1990s, he pivoted and he re-envisioned it as a web of meaning, the semantic web. So the creators of the semantic web, and this includes James Hendler, intended the semantic web and RDF to be data-centric and machine readable so that agents could act on behalf of humans. Why that matters today is that AI needs meaning to better understand content in a machine sense so that it can succeed. So this has seen the reemergence of RDF in the semantic web. Interestingly, Ora Lasla, who's one of the co-creators of RDF, has said that all non-RDF data is now legacy data. And so that would extend to the relational database data that we use in our content management systems. It's an interesting statement and it's something to think about. And so conceptual content modeling, what is the role here? So I would argue that our current content models are still system specific, siloed in the CMS, semantically diluted. I'll give an example of that a little later, and isolated from ecosystem models. So if we don't model our content in a way we can explain or comprehend, we can't expect machines to understand it either. So the logical conclusion is that a conceptual content model distills content meaning, connects content semantically and externally, and better informs AI. We in the industry have actually been doing semantic content modeling for almost 40 years now. This goes back to 87. All these steps along the way have played a role. There are some that will probably be very recognizable to you. So HTML5 semantic elements, schema.org, and most recently, generative engine optimization. But in terms of extending semantics, ontology, RDF into actual web content, there's another two here that are really subtle. One is pattern ontology. The other one is document components ontology. Those really let you structure beyond the page level, deep down into an actual web document and make it semantic. Everyone here may already be familiar, but when you're talking about modeling, there's really three levels: conceptual, logical, physical. So the real thing that we're talking about in this case, in this example, a city, is the area of semantics, ontology, RDF, and graphs. However, it's the logical level where I would argue that most content authoring happens. It's your content types, it's your fields and forms. And then importantly, underneath it is data storage. And traditionally for a CMS, this is relational database. A few other quick terms before we get to the examples. If you're not familiar with ontology, the most common definition out there is a formal specification of a shared conceptualization of a domain of interest. That's another way of saying a way of capturing human understanding and putting it in the loop. The purpose of an ontology is to make human understanding computationally usable. So you may have heard terms like inference and reasoning. Those are directly tied to ontology. But maybe the biggest takeaway I can give you from today's presentation, it comes from John Bittner, as did the previous quote, and that is that every data model already assumes an ontology, whether it admits it or not. And so that's great news because we all have content models. And what it means is that there are already shadows of your semantics in there, and it's just a matter of capturing them in RDF. Resource description framework, I've mentioned a few times. It's really a family. You can look at it that way. It's the foundation for the semantic web, and it's also a W3C standard and framework. It's most commonly seen in triples, and we'll see an example here in a second. Triples. So on this page are 9 triples: subject, predicate, object. And I really like this example. This comes from Trevor Woolacott. He's an ontologist in South Africa. Here we have an example of a document. It could be a web document, anything, but for this purpose, it's web document. It's got a section. And this is where a lot of modeling really cuts out. They leave things at the page level or document level. But so it's really, really great to see an actual section of a document in here. It's got the typical metadata you would expect, so date in this instance, but then it ties into an organizational elements. So it's got an author who also belongs to an organization. It has some topic. And then really interestingly, the section asserts some claim that has its own semantics, and it references some other entity that we don't know what it is. It could be part of the organizational model or some other external model. But I think this is a great example of a content model merging with an organizational model conceptually. Finally, knowledge graphs are vehicles that convey ontologies. GraphRag is probably the most common way you would see this approach used. They express ontologies in huge volumes of instance data. And if you've seen a knowledge graph, as you'll see here in a second, they're inherently visual. So to summarize where we're at so far, the functional definition of a conceptual content model is to elevate the content model from the logical and data levels to the conceptual level using ontology. We want to make our content model a first-class citizen. Then we can embed content instances in the conceptual content model in order to tell a semantic story, a meaningful story, not just for human beings, but for machines. And then finally, we can externalize the conceptual content model to our other ecosystem models in the way that I just showed you in the previous triples example. There are some important considerations of this approach. So first, from a data perspective, it's a shift left. We want to establish semantics at the start versus applying semantics downstream after content is created. This is a complement to GEO, not a replacement. So it also enhances credibility, clarity, and authority alongside GEO. Operationally, you would see a semantic content modeling or conceptual content model approach typically as part of a wider enterprise semantic layer implementation. You can do it as a standalone, but there is a network effect from doing it as part of an enterprise undertaking. And this approach anticipates retooling. So as a product manager, I'm thinking in terms of things like headless for semantics, a conceptual editor along with a typical authoring editor, changes to the authoring UX, and even a CMS that writes directly to RDF. So examples. Radio Television España has probably the most ambitious conceptual content model I've seen. Open that up here for you. And I think what's really amazing about this is not only the richness, but the pairing of their content model with the organizational model. So let's zoom in here. One moment. Okay. So once we zoom in on this, and I mentioned that these graphs are inherently visual. Once you zoom in here, you can see that they've got a really cool intermingling of both content elements and organizational elements. So they have content artifacts. They've got text annotations, text line, subtitling, but then they also have other human or organizational elements such as biography. They have actors in here, crew. They're primarily an audiovisual site, so they have a lot of things involved in media production. So I think this is a great example of how they've graphed all that together. But there's more to their example here because they've built an entire website over this. And so what you get here is a pretty standard looking search experience that's built over their graphed information, built over their conceptual content model. So you can see here search listings that are coming from this RDF data. You can click in to any one of these and you get, again, a standard looking web experience. This is all coming from a graph. The other thing you can do is see related content, and these are the relations that are captured in the graph. One of the really interesting things they've done that I really like is as you're looking at this content here, you can actually download the same RDF that's populating the page. So they really have brought it full circle. I'll move quickly to the next example, which is the Datagraphs site. Datagraphs is a knowledge graph company, but what they've done here is opted not to use a content management system. So they have a conceptual content model, they have an organizational model, and they've blended them together and built a Node.js application on top of the graph. So there is no traditional underlying content management system. It does not mean, however, that they cannot manage content. So they do have here a rich text editor, and they've got ways that they manage their layout and other presentational aspects. What I've prepared in terms of an example for today's demonstration is a modeling of an organizational model. So here we have a contracting unit, a board of directors, business unit, and a legal unit. So this model here shows those business units, the people attached to them, the processes and activities that they're undertaking, and some of the parties to those activities. So in the case, say, of litigation, there could be defendant, plaintiff, things like that. On the side, I have a content model ontology. So this is an example of a conceptual content model. And let me zoom in all the way. And so these are all aspects of content. So for example, I've got content elements, I've got presentational elements, formats, layout, those are largely presentational, but the main one I'm going to rely on today is content unit. This is the functional equivalent conceptually of what you would find in an authoring form. So here, this content unit, you can put whatever metadata you want on it, but it's got traditional title, date, a URI, a unique identifier. But importantly, it's also tied to the content itself. So would be the material component. It's whatever the content is that you're publishing. So it could be a multimedia embed. It could be an external link. It could be a binary file asset, HTML, or some combination of all of these. But really, the beauty of this approach is that when you merge the organizational model with the content model, then you see the full richness of what you can share with AI. So here now, when I merge my conceptual content model with my organizational model, now I have all the elements of my domain. So I've got all the business unit actors that I just mentioned a moment ago. I've got their activities and what they're involved with, but then I've also got the content they're producing. And so what you can see here is that I have, for example, a contracting unit that's issuing an agreement, and the agreement itself has other content units beneath it. These all are content units, and so they actually have material components as well. They can be made of HTML. It really doesn't matter. So you get really a lot of flexibility in how you can model your content. So one of the things I want to call out is the relationship with GEO. So in a conceptual content model, we can still have GEO, and GEO is fine. It's really, I would argue, covering the page level. So what I have depicted here is our page level content or some sort of content unit. We can have both generative engine optimization and RDF working inside that page or that content unit, but we can still wrap it in RDF and then interconnect the RDF. So to summarize, I've been thinking of this in terms of product discovery. Essentially, generative engine optimization, I believe right now, is positioned currently at page level semantics and for the benefit of external AI. So it includes schema, semantic HTML. It's really out there for LLMs to crawl, and it focuses on being found and featured. Whereas currently, RDF has more of an internal AI focus, and it covers organizational and channel semantics. So in this case, the content model is built in RDF. It is the ontology that supplies the graph used in GraphRag. But the good news is that when you're using model context protocol, you can externalize your internal content model out to AI and other models and machines. And the focus of a conceptual content model would be on being understood. So really quickly before we wrap it up for questions and discussion, I want to call out some of the challenges I've seen along the way with traditional content models in terms of how they're set up semantically or not. So I would call this first bucket silos, spillover, and spaghetti. And that's just a way of saying that the content model is siloed in the CMS, but it tries to manage all sorts of things from outside the CMS that may not be content. They could be other organizational entities, such as groups, people, events, activities. One of the systems I work with, we even have a content type for an award. Now, you could naturally have spaghetti, even if you weren't trying to take on organizational elements. You might still have an untidy content model. However, when you are trying to take on organizational elements, it really just compounds the disorganization, and you get content and conceptual structure tangled among all these elements. So content types, sections, fields, markup, metadata. In the end, this is all lost opportunity because the content model is doing all this work, attempting to absorb all these elements, but it's still not using resource description framework. It's not formalizing meaning, and it's not achieving semantic advantage. Some other quick examples. This is what I call meaningless relationships. You can have the best authoring form in the world, best labeled and everything, but it still might not reflect the underlying richness, the RDF heterogeneity that you can get in terms of relationships, dependencies, commonality, and sequence. A great example of this, and I love Drupal. is Drupal's node queue, or excuse me, entity queue. It's a quick way just to tack one kind of some content onto some other list that goes on a page somewhere. But it doesn't really capture why it is you would be doing that or what it is that you're attaching. So for example, when you use a queue like this, is it your top 3 best-selling products? Is it your top 10 accomplishments last year? Is it your, the top 5 vacation recommendations, etc.? So this is just one brief example of that. Another, what I call shadow semantics. I mentioned John Bittner's quote that every data model already assumes an ontology. Well, what that means is if you adopt an approach like this, and I believe that will be advisable in the future, you can go out and look in your existing site, channel, and CMS for the semantics that are already there. So you would look at things like aggregation, even the positioning on a page can be semantic. Your navigation structure is full of semantics, your information architecture, and even some elements of presentation. But one of the current challenges is that all of that is going unformalized by RDF. So the last 2 really quick. I'm a big supporter of taxonomy. I think it's very powerful, great. But it does begin to break down at a certain level of complexity and scalability. So Mike Doinger, who was a former taxonomist, ontologist at LinkedIn, has kind of interestingly referred to taxonomy as connecting data with duct tape, which is an interesting way to look at it. It still has a role, but I think that you want to look at a fuller ontology if you adopt this approach. And then lastly, as I mentioned, generative engine optimization is primarily, I'm getting a little bit of echo, but I'll keep going, is primarily focused on the page level. And that's fine, but with Dublin Core and schema, you're not really reaching outside the page to cover relationships among content or relationships across your organizational channels. And then lastly, semantic HTML, despite its name, is still largely presentational. If you look at the list of semantic HTML elements, they're mostly things like aside, footer, nav, section, table, image. So you're missing out on some deeper meaning there. The advantages of conceptual content, and then I'll bring this to a close. As I mentioned, model context protocol can expose your conceptual content model and its content for querying by internal and external systems. A graph RAG approach using this kind of model can bring retrieval accuracy to as high as 87%. Your model is inherently shareable. You can get very creative with your modeling, as I showed you a moment ago. You get tremendous observability. I showed you only a few of the aspects you can overlay over a model, but you can add to this model things like permissions, namespaces, channels where things are published, storage, and then you can drill down to various elements. Contactless content management is a big one for me. When you're using an ontology, you get the benefits of inference and reasoning. And so what this means is that many elements of your content operations can be abstracted and automated. So for example, you can drive personalization from reasoning over the model, or if you're involved in a content audit or inventory, you don't have to do a lot of bulk tagging necessarily. You can make some small adjustments in your model, and through the power of inference, you can have new values take effect across your different content elements. Lastly, even though I de-emphasized the CMS and channels at the beginning, there are still presentational benefits to using conceptual content. You can customize the model, you can build experiences over it, and you can use the power of the semantics in your model to depict complex processes, timelines, relationships. And then finally, if I had to do it all over today with a new website, I would probably focus almost all my time on a model like this, and then throw it all open on the homepage and just tell everybody, look, here are all of our public concepts, relationships, and instances. You can have this and do what you want with it. You can sort it, you can filter it, you can build your own theme over it, you can make it available through MCP, whatever you want to do. So I leave you with this. If you want to get started with this approach, reach out to the Semantic and Knowledge Graph community. They're a great community. You learn a lot, even when people are disagreeing with each other. You'll be using your mind a lot in RDF. There are some great tools like Grapho and Protege, but I would advise not relying on spreadsheets, which is really more of a relational database approach. Of course, you're going to want to model your organization. You don't have to model everything. You can start with a few subdomains whose stories you want to tell more meaningfully. You're obviously going to model your content, but again, you can look for semantics in overlooked areas that I mentioned before: aggregation, information architecture, navigation, etc. And then lastly, I showed the connection between the content model and the organizational model. And of course, you're going to want to blend the two models. But you can go beyond that. Ultimately, you can reach out to other upper ontologies. You can blend with other systems, machines, models, etc. To conclude, I'll leave you with some of the points that Giannis mentioned at the beginning, which is, we have an obligation to know our content better than AI, and to capture the semantics that are already in our systems and sites. One way of doing this is to really evaluate content and semantics in a vacuum. It's kind of a thought experiment, but you can do this using hypothetical scenarios where there is no CMS or channel. Another word for this exercise might be event storming, where you have everybody involved in some process or procedure involving content. Everybody sits down and kind of agrees, like, what's it about? What's really going on? And then finally, in the dialogue between content and machines, what we have to remember is that what you model is what you get. So I hope we're still doing good on time. I'll leave it there. Thank you.
Really appreciate it. We do have a minute or three for comments, reflections, questions. I think we covered quite a lot in these 30 minutes. And so I know many people will also be looking at the slides later. I will share them, turn them into a blog post, Mark, as per tradition, together with the recording. Any questions, comments, reflections? I think perhaps you overwhelmed them, Mark. a lot of good stuff here. I love to see I love this ontology navigator. Very, very fascinating to see this connection between all the different objects. And I think also you have managed to sneak in a somewhat provocative point in there by saying that all content in the systems that we know today, like called CMS and DXP, are legacy content.
Yeah, that was Oral Asala, but I tend to agree with him. Yeah, all non-RDF data is legacy data.
Ollie, did you have a question?
Could I just quickly, a quick question, just as a devil's advocate, if I get the history right, then there was a lot of talk about semantic web in the 90s, but then it didn't really catch the development of web. Perhaps one of the reasons was that Google came along and sort of started crawling everything and making these connections, and it was messy, but it sort of worked. And I'm just wondering whether there is the situation now similar or somehow different, that we actually need this kind of semantic for the semantic kind of content modeling in order to be found by AI and other applications, or are we in kind of similar? So can we sort of see that the future might be similar, that it's a mess, but there's the AI probably figures it, all the connections out.
Interesting. I'll leave that with you, Mark. I know it's not a yes or no, but perhaps a brief answer you can offer.
Well, I think the irony, as James Hendler put it, is that Google was quick to claim Google Knowledge Graph some time ago, and so I think even they saw the value. But what I think's really changed it now is AI and the need to resolve, entities and achieve certainty in the information you're getting back. And so that's where these graphs, these ontologies, these conceptual content models really contribute.
There was also a question in there from Ravi from Harvard Business School. Best way of convincing others in the organization of the value of these approaches? I think that's the common question all around. All right, that's fine and good, Mark, but what's the business case,
Yeah, so one of the slides I had to leave out was adoption patterns. if you're lucky enough to be a Netflix, everybody's already on board with this approach, and it's just a matter of working out the details. The other pattern is to start with a small subdomain, as I showed here. And Dave McComb with Semantic Arts talks a lot about this. You start with a small subdomain, you show success there. It's a traditional product pattern. And then you don't even have to speak in terms of ontology. You just show your success, and that's the way to get the buy-in.
Step by step. Thank you very much, Mark. That's all we have. Really appreciate you getting up early in Los Angeles and joining us and sharing your insights. Really appreciate it. Thank you, Mark.
Thank you.
Thanks for having me. See ya.
Thanks very much.